Good afternoon. My name is Don Arnone. I'm the CEO and co-founder of TerraView. Thank you for taking time to listen to our presentation today. I'd like to say a few words, if we may, about our company, our business, and the investment opportunity at TerraView. Just to say a few words in overview before we start our presentation. One of the frequently asked questions we have is why we're looking at a IPO in Korea for TerraView. There's a number of reasons for this. One is that in TerraView's target markets, which is the inspection of AI chips in the semiconductor industry, and also the inspection of lithium-ion batteries in the automotive industry. In both areas, we have blue chip Korean customers. These customers have been working with us for a number of years, and they're now moving our technology from the lab into production environments. As part of that move, they have asked TerraView to show a commitment to increasing our operations in Korea so we can support their use of our equipment in their production facilities. Our visible way of expressing that commitment is to do an IPO in Korea, which would lead to an increase in the size of our operations in Korea, particularly for customer support. So that is one of the key commercial motivations for the listing in Korea, is to show commitment to our customers who are investing in our technology for production. Another key driver for the IPO in Korea is that TerraView would like to start to do a portion of its manufacturing in Korea. At the moment, our products involve a terahertz sensor combined with automation, which could be robotics, scanning stages, or other means. What we would like to do in some of our markets is to start to work with partners in Korea who can add automation to our sensors. It could be done in Korea more quickly, and it could then be integrated more seamlessly into customer production lines. So establishing an operation in Korea that helps us with manufacturing and integration and work with Korean automation partners is key, and is another driver behind the IPO. A third reason for looking at an IPO in Korea is that our business is becoming increasingly focused on Asia. Singapore, Malaysia, Taiwan represent important markets for the company where we hope to establish offices over the next several years. We want Korea to be the hub for our Asian business, supporting our business as it grows in Korea, but also beyond Korea to the greater Asia region. And finally, there is an excellent opportunity for TerraView to exploit new technology, exciting technologies that are developed in Korea. If we are close to those technology developments, close to market needs, we can actually do product development with Korean customers more quickly and get to market more quickly than our competitors on the basis of this collaboration. So establishing R&D teams in Korea is also key. All of these are reasons why the IPO in Korea is very important for TerraView. One of the other frequently asked questions is, what is terahertz? Terahertz light is the last commercially unexploited region of the radio and light wave spectrum. We lie between radio waves on low frequencies and light and photonics at higher frequencies. Our technology uses radiation that's about 50 times higher in frequency than your mobile phone. The reason that terahertz light is so important and has advantages is that it penetrates through many common objects, so you can essentially see below the surface at what is inside. Moreover, if you compare it to other techniques such as X-ray, terahertz is very sensitive to small defects, micro cracks, and other sorts of defects that conventional technologies aren't. The other ability of terahertz light, aside from sensitivity to defects, is its ability to measure the thickness and density of coating layers. And this applies to a wide variety of industries. Coatings used in lithium-ion batteries, coating used in automotive paints and aerospace coatings, and other areas. So these unique properties of terahertz make it very useful and very important for many of our customers. In many areas, it's a substitute for X-ray, but a particular area of interest is 3D packaging, which is now extensively used by the semiconductor industry in AI chip production. 3D packaging essentially connects a GPU with a HBM memory device It's the electronics and the materials that connect those two devices. Terahertz was originally developed as an inspection tool as a collaboration between TerraView and Intel, and it is ideal for looking at small defects, micro cracks, in advanced packaging. Another advantage of terahertz is that it can detect faults and defects that electrical testing, also used in the electronics industry and the semiconductor industry, cannot detect. More recently, Nvidia have made a number of public announcements through publications in U.S. Semiconductor conferences, demonstrating that terahertz is now a very effective failure analysis and quality assurance tool, and that is used in many instances ahead of electrical testing and other techniques. What that means for the semiconductor value chain and the role that terahertz plays in it is that we not only work with the AI companies, Nvidia and AMD, who have publicly commented on our technology through publications and industry events, but those AI companies are also recommending to their suppliers that they adopt terahertz as a failure analysis and as a quality assurance tool. That includes some of the foundries, as you can see here, but it also includes more recently OSATs, who do the assembly and test. So we have a role throughout the semiconductor value chain, throughout the AI chip essentially, in inspecting the quality and doing failure analysis on different components of a AI chip. Lastly, there are many new entrants to the AI market in terms of developing AI chips, and many of those customers are working with TerraView and have acquired our technology. So AI chip providers are in many ways TerraView's best means of actually deploying its technology to the wider customer base. In terms of TerraView itself, it's a 48-person operation located in Cambridge, UK. We've had a Korean office up and running for quite a number of years, for several years. We have currently have 6 members of staff in Korea, but we see that increasing quite dramatically over the next 18 to 24 months as part of the IPO. The history of the company, you can see here, we spent several years developing semiconductor technology with Intel and Samsung, adding automation to our inspection tool in the semiconductor market so that it could be used closer to production. We've gone through a similar process recently with automotive customers. We worked with Ford Motor to develop a terahertz system called Terra Cotta that is used for multi-layer paints. And more recently, we worked with major US and Korean battery manufacturers to demonstrate in production environments the capabilities of our Terra Cotta product for coating inspection. These are coatings used on electrodes in lithium-ion batteries. In terms of a research team, this is a brief overview of our R&D team. Professor Sir Michael Pepper is our CTO. He's also the co-founder of TerraView. Michael has been acknowledged in many countries for his contribution to semiconductor physics throughout the years, and more recently in TerraView and terahertz physics. Mike's expertise is backed up by a team of PhDs, many of whom are pioneers in the terahertz area and developed much of the technology and many of the applications that we'll see today in this brief presentation. We also have a very strong commercial team who've come in and been recruited from the semiconductor industry, as well as the automotive and high-value coatings industries, to build up our commercial activity and our commercial teams, pre- and post-sales customer support. Our product itself, in terms of the semiconductor market, is called EOTPR. EOTPR 4500 is the product that you see here. This is our latest product. It's a semi-automated system. So users load samples, push a button, and then probing is done of various contacts on the chip. This is very good and developed for failure analysis. It's recently been extended to quality assurance. So you could do batch testing on this, looking for faults or defects on a number of chips in a batch, and that can be used for quality verification purposes. The company does have competition in this area, which is fortunate. If there was no competition, there wouldn't be a market. One of the large Japanese companies, Advantest, also have their own product. The advantage that TerraView has is that we've been in this market for quite some time, and we have substantial IP as well as expertise within our team. In terms of patents, we have 40 patents and patent applications covering this product and related products. This gives you an idea of, again, the rollout of the technology, the rollout of the EOTPR series, product series, over the last several years. Up until recently, we've been completing automation and completing software. Product development is an ongoing process, but with the advent of AI and its importance over the last 18 to 24 months, you can see deployments with some of our key customers increasing. And this is set to be a trend going forward. As the industry needs advanced packaging for AI, then the industry also needs EOTPR to inspect that advanced packaging. So as advanced AI expands and AI grows, TerraView's business will grow. In the automotive and high-value coatings area, we have our Terra Cotta product. Two incarnations of it can be seen here. On the left-hand side, this is our Terra Cotta 3000 instrument. It's used to measure multi-layer paints. As I mentioned earlier, it was developed with Ford Motor. We're now commercializing with Ford, VW, and other customers, both in Korea, in the US, and also throughout the world. This product enables automotive customers to improve quality, and it also enables them to increase production efficiency, production throughput. By measuring the coatings quickly and ensuring they're of the right thickness and quality, that results in up to 25% increase in production efficiency in a production line, typical automotive production line per year. On the right-hand side, a different incarnation is the Terra Cotta 3500. It's the same core unit, but it has a different probe and software. This was developed with major US and Korean battery manufacturers, and it's now actively being used in pilot production lines in Korea. By measuring the thickness and the density of coatings, automotive battery manufacturers can reduce their costs by 30%, and they can increase the quality and efficiency, and most importantly, the performance of their batteries. In terms of the dynamics and growth potential for some of our markets that we've just covered, one of the key drivers in the semiconductor market at the moment behind AI is the development of HBM devices. This is obviously particularly important in the Korean market. There is a move now from HBM3 to HBM4. And as that move occurs, that progression occurs, our EOTPR product plays a very important role. With increased complexity comes increased faults and lower yields, and our product can be used to very quickly identify failures and correct yields. It can also be used after that process to modify and monitor the quality of products. So there is a quality verification application of EOTPR as well as a failure analysis application. And this is being used across a range of HBM companies. Major Korean companies and also major US companies are using our technology. And again, the advent of HBM4 represents another growth opportunity for our technology. One of our biggest advocates of terahertz technology in the semiconductor area is Nvidia. We've had the honor of working with Nvidia for a number of years. They've helped us refine our automation and other aspects of our product. At a recent trade show in the US in April of this year, they made the announcement that EOTPR, our semiconductor inspection system, had been moved from second or third in their workflow all the way up to first in the workflow. So essentially, EOTPR is used for failure analysis and other applications before other technologies such as X-ray or in some cases electrical testing. This is a fairly recent announcement, and it's quite an exciting announcement for the company. It demonstrates to the industry the importance of EOTPR as a frontline failure analysis and quality assurance tool. This is some data that actually lies behind that decision and that announcement. On the left-hand side, you see electrical measurements done on a standard ATE, automated testing equipment system. In this particular case, the contacts that correspond to the different colors here would pass. The terahertz diagram on the right-hand side demonstrates differences between the different contacts. In particular, as you can see, terahertz has identified micro cracks in the device that the electrical testing on the left was unable to pick up. So this shows the power of the EOTPR technique. It's this ability to look at micro cracks that are not detected with electrical testing or not detected with X-ray. Again, this has applications throughout the semiconductor development and manufacturing process. We're used in failure analysis, we're used in quality assurance, and our aspiration going forward is to add additional software, hardware, and automation in order that we can move closer to the production line, with the goal of having a EOTPR system associated with every major ATE electrical testing system used in manufacturing. Behind all of this innovation and all of our products is our core IP. We have core IP in 3 areas. On the left-hand side, we have key patents on the generation, detection, and collection of terahertz light. Many of these patents have been extended, so new innovations have been included. The company is filing on average an extra 3 to 4 patents, new patents every year. In addition to the hardware to generate, detect, and collect terahertz, we also have patents on the analysis of terahertz light that's been reflected or collected from an object. And that is necessary to give the customers the required information. So whether it's isolating the position of a fault in a semiconductor or accurately measuring the thickness of a layer in a lithium-ion battery, we have IP on the methods and the algorithms that actually yield that information. And then finally, we have automation capabilities in terms of how terahertz is used to rapidly inspect semiconductors and multi-layer coatings. And the company has core IP in that area also. This gives us 2 important abilities. One is we can work very rapidly with customers because all of this know-how is in-house. No other competitor has the ability to produce both hardware and software in-house and rapidly optimize it for customer needs. It also means that since we control all of the IP in our product, we can drive costs down and improve margin going forward. In terms of revenue growth, the company has seen modest revenue growth over the last couple of years. That has changed, however, over the last 12 to 18 months, where our order book has increased by 100%. This again reflects the fact that AI is now strongly driving the adoption of advanced packaging. And it also reflects the fact that we have got to a point in our products where we have sufficient automation, software, and hardware to drive adoption of our technology for not just failure analysis, but also for quality assurance techniques and applications. What that means is we're seeing a rapidly expanding market for our technology. And this doubling of revenues is what we're targeting to continue for the next couple of years. For the projections that you see here, we have very good information and very good relationships with all the customers that contribute to the numbers depicted here. Most of them are Fortune 500 companies that we worked with for a number of years and we do repeat business with. Another key aspect of this is automation. To get to even higher, larger market opportunities, we need to automate our product. Automation basically gives us the opportunity to do very high throughput inspection, whether it's in semiconductors, advanced packaging, which is the system we're showing here, which we've successfully prototyped in the past, and we're raising money to do further development on, or whether it's automation in the automotive area. Higher throughput in both markets equates to larger sales opportunities. So in addition to selling the current product, which underlie the projections that we reviewed previously, selling this product will also open up new market segments for the company. Similar developments in terms of automation are being applied to automotive paints and also to lithium-ion battery inspection. Again, the focus being on completion of software and hardware for optimizing it for what customers' growing needs, but also increasing throughput as a kind of theme in all our products to increase sales. I should mention, however, that although we have product development activities going on, our revenue projections are largely predicated on our existing products, which are in a complete state and being sold on to customers as relatively mature products. And finally, there are market opportunities beyond our core markets, our target markets that we just discussed. The company is actively selling to European defense contractors who are using our technology for looking at coatings on aircraft. We similarly have contracts with large US engine manufacturers who are using our technology to look at thermal barriers on turbine blades and jet engines. This shows the diversity and the power of the technology to look at different types of applications in different markets. The applications you see depicted here, many of them are based on our Terra Cotta product and are also based on sales that have already been completed with customers. These numbers are not included in our projections, and they represent an upside opportunity for the company going forward to grow its revenues. And finally, coming back to the first discussion item, we're here today because we're talking about a very exciting opportunity to become the first UK and indeed the first European company to float on KOSDAQ. The drivers for that are very simple. They're commercial. We want to support our customers and support manufacturing in Korea and the greater Asia region where a majority of our customers are. We want to enhance cooperation between the UK and Korea, both of whom have a long tradition of developing and commercializing technology. So I thank you very much for your attention today, and we very much welcome the addition of new Korean investors to our company. It's been a great journey so far at TerraView, and there's an even more exciting journey ahead, and we look forward to you being a part of that. Thank you for your time.